Right now you will be designing a bolt connection. Here they have asked the content of lap joint. So what do you mean by a lap joint is, you know that if two members, this is member 1 and member 2, if these two has to be connected, then this type of joint is called a lap joint. When you are connecting the two members at the edges, it will be a butt joint and you will be having additional plates. And they have not given any bolt, how many number of bolts should be used and what is the spacing which has to be provided. These two component you have to design. So what do you mean by a design in steel structure is regarding connection. So you will be giving the bolt dia, how many number of bolts are required, at what distance you have to provide. In this example you have a bolt here and this bolt has to be connected between these two members. That is, you need a distance from the edge of the plate as well as the three edges, how many number of bolts are required. So this is known as a design. This has to transmit a 70 kilonewton load. So a tensile force is applied between the member. So two member is being, this is a plate which is being tensioned, you have to connect with a bolt. Okay, using M16 bolt. So what do you mean by M16? 16 mm dia of bolt. So M16 stands for 16 mm diameter and the grade of bolt is 4.6. So what do you mean by 4.6 is 400 Newton per mm square. So 4 stands for 400, 6 stands for, that is 0.6 stands for 400 into 0.6. 240 is your yield strength. So 400 is Fu and what is Fy? Fy is yield strength. There are two technical components here. What are they? First one is plate and second one is bolt. Plate components are given and bolt component you have to find. So plate grade is 410 Newton per mm square. So this is the grade which is given. Okay. Now you have to find the solution. So in designing of a bolted connection, you need to check for two components. What are they is design for shear, design for bearing. Code book, and in that class 10.3.3 page number 75 you can find this class. This class states that the design strength of bolt VDB as governed shear strength is given by, they have given the formula. So you can find by using this formula. Now if you want to design for this shear, what is the formula? You have to find nominal shear capacity of the bolt, Vn. Vn equal to nominal shear capacity of the bolt. Now how to find Vn? Here they have given the formula which is Fy divided by root 3 n suffix n ASB plus n suffix s ASB. Fu. Do you know Fu? Fu is 400. You know that. Then n suffix n, that is number of shear planes with the threads intercepting. So how many shear planes are there? If you have any material and if a material is being pushed by a single force, you will be having a single shear. When you are having 3 number of plates, you will be having double shear. Since you have only 2 plates here, so this is a bolt here. If you push this member towards left hand side and this as right hand side, the bolt will be subjected to shear. 2 equal and opposite force will be there. So due to that you will be having a single shear. So you can take it as 1. So this will be taken as 1 here. Then you are having n suffix n, which is number of shear planes with thread intercepting the shear plane. So here they have given along with the description. Okay, since you do not have any shrank, so you have two components, one is shrank and another one is thread. In a bolt you have these two components. So I have given in previous class. What is shrank? Yes. See, in a bolt you will be having 2 number of portions. What is that? This is strang portion and this is thread portion. So you will be not having thread till the end of the bolt. Some portions will be having without any thread. So this is the portion of strang and this is the portion of thread. So a bolt consists of these two elements. If you are having more than single shear, you will be having the member at the strang portion. Since in this problem you are having only single shear, you will be not having any strang portion, hence you can take it as 0. Yes. See, this component will become 0 if n of s. What do you mean by n of s? Strang numbers. So they have given here, if this is 0, so this component will become 0 and you are having nn into A and B. What is A and B is? Net bearing area. N is known as net, B is known as bearing area. A and B is net bearing area. How to find net bearing area? You have this formula. So take it down. A and B equal to 0.78 pi d square by 4. Now what is your diameter here? 16. You can find your area of the bolt, 157. Now multiply with this component, you will be getting 29 kilonewton. You have to divide it by gamma MB. So what is gamma MB? Which is material safety factor. Material bearing safety. Gamma is safety, M is material, B is bearing. Material bearing safety. Now after multiplying this, you will be dividing by gamma M. Material safety is 1.25, yes or no? So you have that material safety and you can take that 1.25 and your answer will be 29 kilonewton. You will be getting this in terms of Newton, you have to make it as kilonewton. Next component is bearing capacity of the bolt. Now comes the second formula, which is bearing capacity. Shear capacity is over. How much shear capacity this bolt can take? 29 kilonewton only it can take. If you are applying more than that force, what will happen? This bolt will break. Now what is the force which is acting here? 70. So a single bolt will be taking only 29 kilonewton. So what will happen? If you provide only a single bolt, is either this member is going to shear or not. This will be break. Why? Because its capacity is 29 and the force which is applied is 70 kilonewton. Okay, let this be here. Next you find the bearing capacity. Nominal bearing strength of bolt. How to find that? The formula is 2.5 kb d T into Fu. Take down the thickness of the plate is 12 mm and 20 mm. So you have two number of thickness of plate. Now these three are your formulas. Now first one, what is E? You have to find E component. So what do you mean by E? E is end and P is known as pitch distance. So end and pitch distance of the fasteners. What do you mean by fastener? Either this plate or this bolt. Bolt is the fastener. So they will be giving another term. Do not get confused. Bolt is otherwise known as what? Fasteners. Okay. So they have given that end and pitch distance of the fasteners along the direction. Okay. Do you know DO? What do you mean by DO? Nominal diameter of the hole. So how to find the diameter of the hole is the table 19. At the page 73 you have clearance of fasteners. So which diameter is your case? So nominal size of fastener they have given here. Does it comes under 12 to 14 mm? What is the dia of your bolt? 16 mm. So 16 to 22 is your case here. So for this case, what is the standard clearance in diameter of the width? 2. See what they are saying is, if you are making a connection here, if your bolt mm is 16 mm, you should drive the hole in the plate, yes or no? If you are driving the hole, it should be greater. How much it should be greater? If you are providing 16 mm dia bolt, you should make plus 2. What is 16 plus 2? 18. So your hole should be 18 mm. If the hole is less, the bolt will not sit there. If the hole is exactly right, there will be having friction. So minimum 2 mm is required. So according to the diameter of the bolt, if you are using larger diameter, that is 24 mm diameter, size of the hole should be 3 mm. 24 plus 3, 27. So your hole should be 27. So this is the way you have to understand. Now if your bolt is 16 mm, what is your diameter of the hole? 18 mm. What is FUB? Is ultimate tensile strength of bolt and ultimate tensile strength of plate. So what is FUB? FU is ultimate strength of B stands for bolt. What is the ultimate strength of bolt? 400. What is ultimate strength of plate? They have given in data. 410. So you have to divide 400 divided by 410, you will be getting that answer. You got 0.97, yes. Okay, you need E. What do you mean by E is edge distance. What is the formula? They have given in class 10.2.2. Take down class 10.2.2. Minimum spacing. So they have given the fasteners of minimum spacing. So what is the formula? The distance between the fasteners shall not be less than what? 2.5. Now 2.5 times the nominal diameter. Now what is your nominal diameter? 16 mm. So you multiply 16 into 2.5. You will be getting what? 40 as your first answer. Then minimum edge distance. For that you have the class 10.2.4.2. The minimum edge distance and end distance from the center of any hole nearest to the end of the plate shall be not less than what? 1.7 times the diameter of the hole. Case of sheared or hand flame cut edges, and 1.5 times the diameter of the hole in case of rolled. If you are using a planed edge, so your plates are having definite edge, yes or no? It is a definite edge, hence you can use 1.5 times the dia of the hole. 27. Now you can find KB. So what is your edge distance? 27 divided by 3 into DO. What is DO? 16 or 18? 18. Exactly 0.5. Okay. Now you find second answer as P divided by 3 into DO. So what is P is known as pitch. What is your pitch answer? 40 divided by 3 into 18. 0.74. Okay. Now the minus 0.25. Here you have minus 0.25. 0.75 minus 0.25. 0.49. Then your third answer is F of UB by FU. That is 400 divided by 410. What is your answer? 0.97. So you will be getting, you have to take KB as the smallest value. What is your smallest value? 0.49. Now in this formula you can substitute 2.5. What is your KB? 0.49, which is the smallest value. Diameter is 16. What is T? You have two plate thickness. First plate is 12 mm and second plate is 20 mm. You have to take the smallest thickness of the plate, which is weaker. You have to take that. Now, so you have to take 12 mm. So thickness is 12, and what is FU? You know plate ultimate strength, which is 410 divided by gamma MB. You know gamma MB as 1.25. Are you getting 77.15? Okay, you got two values. What are they? You got the shear strength of the bolt and bearing strength. What is your shear strength? 29 kilonewton. What is the bearing strength of the bolt? 77. So at 29 kilonewton of load, the bolt will shear and it will fail. If you are applying that 70 kilonewton, see this is your plate and you are applying 70 kilonewton force. If you are applying 70 kilonewton, either this bolt is going to take all 70 kilonewton force in a single bolt. No, at 29 kilonewton it will fail. So your design has to be considered for the least. Okay, how many number of bolt is required to carry 70 kilonewton? If one bolt can carry 29 kilonewton, how many bolts are required? 70 divided by 29. So what is your answer? 2.4. Around 3 bolts you require. If you provide 3 bolt, what will be the strength of 3 bolt? 29 into 3 is how much? 87. Now what is the force which is applied here? 70. Either this 3 bolt can take care of the force? Yes. Now this is your design. Now you have completed. Okay, what about the bearing strength? 77. What is the force coming to the plate? 70. Is it greater than 70? Yes. Make sure that for shear strength your bolt should have higher, and for bearing strength you should get higher value. If both the things are higher, your design is safe. Now finally, what is your design which you are given here is, you have provided 3 number of bolt. Why you are providing 3 bolt? You can provide 2 bolt? No. Why you cannot provide 3 bolt? Why you have provided 3 bolt here? Because 1 bolt is having how much shear force? 29. If you provide 2 bolt, what will happen? It is not sufficient. If you provide 3 bolt, then it is sufficient to carry 70 kilonewton of force. Okay. What is edge distance is, see, you have a plate here, this is the edge of the plate. From the edge of the plate you cannot bolt exactly at the edge. Have you seen in any steel structure, exactly at the edge of the structure, have they provided any bolt? No. If they are providing, it will break immediately. You should have some distance as the edge. So this is known as edge distance. How much you have found out? Minimum edge distance you have found out, no? 1.5 times the dia of hole. What is that? 1.5 times 18 is how much? You got 27. So minimum 27 is required. You can provide 30. So here they have provided 30, but you should not below 27. You can go up to 30. They have provided 30 here. Okay. Now what is pitch is distance between the 2 bolt. So what is the minimum condition there? 2.5 times what? 2.5 times diameter of the hole. What is the answer you got? 40. So they have provided distance between 2 bolt is 40. Now your design is over. Your detailing is pitch distance is 40 mm. Find the efficiency of the lap joint shown in figure. Given M20 bolt of grade 4.6 and FE 410 grade of plates used. So 2 components they will be giving, grade of bolt and grade of plate. Here they have given in this figure that 2 plates are being connected. In the previous problem, either the 2 plates are same thickness. No, you had a smaller, that is leaner plate, and the thicker plate. Here in the second problem, both the plates are having same thickness, that is 20 mm. Okay. Now they are using M20 bolt. What do you mean by M20? 20 mm dia bolt. Then how much of hole diameter you have to provide? If your bolt is 20 mm dia, check that what is the hole you have to drive? 20 plus 2. You have to provide a hole of 22. Okay. They have given a grade of 4.6. The same grade. So by this you can write in given data. Below that you write given data. FU for bolt. FUB equals how much? 400 Newton per mm square. Below that you write Fy equal to 400 into 0.6. How we got 0.6? If the grade was 4.8, then you have to multiply 400 into 0.8. Since this is 0.6, multiply 400 into 0.6, which will be 240. Now partial safety factor they have given us 1.25. What is efficiency of the joint? Efficiency is the plate will be having different capacity and the bolt will be having capacity, that is strength bearing capacity. You have to relate that and find. In hydraulics you would have found the same efficiency. What do you mean by efficiency in hydraulics? If your turbine is having 33% efficiency and a Kaplan turbine might have 52% efficiency, which turbine you will be using for your power generation? 33 or 52? 53. Now, what are the check you have to do? Last problem, what are the check you have done? Shear and bearing. Do you have the same formula? Check the same formula, that is check for bearing and check for shear. These two things you have to find for the bolt. Now you have to find the efficiency is you have to find the bearing capacity of the plate. So the plate capacity how to find is take down class 6.3, page 32. You have plates. 6.3.1 is known as plates. Okay, do you have this formula TDN? TDN is design strength in tension. How to find the strength? 0.9 ANFU divided by gamma M. Do you know FU? Ultimate strength of plate is 410. Do you know gamma? 1.25. Only one component you have to find AN. How to find AN? Either they have given any formula. Below that you check. Do you have any formula? Yes. What is AN? B minus N D H plus summation of PSI divided by 4G. This pitch and gauge will be there for staggering pitch only. Okay. Now what is B? They have given what do you mean by B? B is known as what? Width and thickness of the plate. Now what is your width of the plate? What is the width of the plate? B is 180. What is the thickness of the plate? 20. You know the two component B and D. So what do you mean by DN? Diameter of the hole 20 plus 2, which is 22, and another component is number of bolts in the critical section. For a section, how many number of bolts you have? Take down this as a section. If you cut this, how many dias will come? 3 number of dia. So you have to take N as 3. Now you find area. How will you find area? Number of bolt in holes is 3. If you are having staggering pitch, what do you mean by staggering is, see, if your problem is given like this, if you have bolt in zigzag pattern, this is known as what? Staggering. This type of alignment is known as staggering, and when you are having staggering type of bolt connection, you have to use this component, summation of P divided by 4G. This component you have to use. Are you having this kind of pattern in your problem? No. Hence you can take it as 0 and you can only find B minus N suffix D. You know B is what? 180 minus N is 3. Dia of hole is what? 22. And what is thickness of plate? Thickness is 20. You multiply all the component, you will be getting area 2280. Now if you know AN, multiply all the component, you will be getting 673 kilonewton. Now you have found out the plate strength, how much of force the plate can carry. If you are going beyond 673, that is if you are applying 680 kilonewton, the plate will break. What are the other component? Bolt. So you should check to how much force the bolt can carry. Okay, now what is your formula? For strength of bolt, First check for shear. For checking the shear, you write it down the class. Class is 10.3.3 per 75. You check it, you have these two formulas. So this is design shear strength of a bolt, VDB. How to find it? V, shear force, that is nominal shear of bolt. How to find nominal shear? Fy divided by root 3 ns plus asb and nn. Okay, so when you will be having ns is when you have shear planes without threads intercepting the shear plane, and what is nn is number of shear planes with threads intercepting the shear plane, and nominal area of plane strength of the bolt and net shear area of the bolt at thread, and it may be taken as corresponding to root diameter, thread diameter. Okay, what is n suffix n? Number of shear planes. See, if two forces are acting, one force is pulling this right side and this one is towards the left side. So how many shear force will be acting? Either one shear or double shear. If you are having three number of plates, you will be having two shears. If you have only two plates, only single shear will be there. So there is a difference between single shear and double shear, which I will explain when you are dealing with that. Right now you take this as single shear. If I am forcing, that is tensioning two plates, you will be having single shear only. N suffix n will be 1 and number of shear planes at strength will be 0. If you are having more than two plates, then you will be having this case. Now total number of shear planes is, how many bolts you have? 6 number of bolts, and n suffix n, number of shear planes with thread is 6. And how to find A and B? You have the formula in previous example, in previous problem you had this formula, 0.785 d square divided by 4. Now what is your diameter here? See, you have two diameter, one is diameter of hole and diameter of bolt. In what you are doing now? Are you testing the bolt or are you testing the plate? Bolt. Then you should substitute diameter of the bolt only. When dealing with the plates, the hole is drilled only on the plate, yes or no? The hole is drilled on the plate. When you are designing the bolt, you should apply only diameter of bolt. 245 mm square, you will be getting that. If you know n suffix n and A and B, both the components are known, this component is 0. Now can you find shear strength of bolt? Nominal shear strength of bolt, NSB. F equal to ultimate strength of bolt. It is given in the data itself. What is ultimate strength of bolt? 400. So 400 divided by root 3, 6 into 245, 339.482 kilonewton. See, the plate is taking 673 force and the bolt is only taking how much? 339. If you are applying 339 force, which will break now? Bolt will first break. Plate will be good. Plate will not break there. And first component, see, whenever you are designing, you know that if you are applying which force, either bolt will fail or plate will fail. You can find it now itself. So now when checking the shear force, we found that it is failing for the shear at 339 kilonewton itself. Okay, now what is the design shear strength? What is gamma MB? Gamma MB, which is given, gamma MB is 1.25. If you divide it, 271.586. So this is design shear strength. Even though it may carry 339.48 kilonewton, due to material, you are reducing the safety factor and you are taking 271.58. At 271.58 the material will break. So you are taking the safest load. Now what is the next case? Design for bearing. So design strength for bearing. So what is the case now? You write class 10.3.4. You write the class and what is the page number? That is 75. So you write the title here and the formula is given here. 2.5 kb dtfu. What is kb? kb is a constant. You should find least of the all the cases. You have 4 cases. What is the first case? E divided by 3d naught. What is E here? E is known as end distance. So what is the edge distance for this plate? 30 mm. Now you know E equal to 30. What is D naught? Diameter of the hole. What? 22. 0.454. Are you getting that? Yes. What is second case? P divided by 3D naught. What is P? P is known as pitch. What is pitch for your case? 60 mm. So pitch is 60 mm divided by 3 into 22. So this is 0.4545 and for second case 0.909 minus 0.25. 0.659. This will be your answer. Now the third case is FUB, that is ultimate strength of bolt divided by ultimate strength of plate. What is ultimate strength of bolt? 400. What is ultimate strength of plate? 410. You divide this two. You will be getting one answer, which is 0.9756. Now what is the last case is 1. Which is least of all the 4 cases? 0.4545. Okay, now your KB will be 0.4545. What is D here? D is known as nominal diameter of bolt. What is that? 20. And what is T? Thickness of plate, same 20. And what is FU? Ultimate strength around 186.34 you will be getting. So make it as kilonewton. So if you divide by factor of safety, how will you find design strength? Divided by 1.25. 149 kilonewton. This is for a single bolt. So like that, how many bolts are there? 6 number of bolt. You multiply into 6. 149 into 6 will be 894 into 10 power 3 Newton. You will be getting 894 kilonewton. All the bolt will be able to carry with a bearing force of 894. Now within this 3 force, which is higher? 894, the bearing capacity of the bolt is first higher, and what is second higher? Plate bearing capacity, which is around 670, and the least of that is what? Shear. So your plate will first fail due to which force? Shear. Before constructing itself, you can say that if this is the design, your member will fail due to shear. Okay, now how to find the efficiency is design strength of bolt in a joint equal to 271. So this is your strength of the bolt, which is lesser than TDN. Strength of the joint is 271. Can you recollect this 271? What is that? Here you check that. Next, how to find efficiency is you are providing a plate and a bolt. Now you are checking the efficiency. What is the area of solid plate is 180 is the breadth and thickness is 20 mm. This is the solid plate, and if you are finding the design strength of plate, formula is Fy into A divided by gamma mb. This is a simple formula. How to find stress? What is the formula for stress? Axial stress is force by area. Now your force you have to find. Stress it is given as what is Fy is stress, yield stress. Fy is known as yield. What is the yield stress of your material? 250 they have given in the data, and into area of the plate is 3600 divided by 1.1. Okay, if you divide that you will be getting 818 into 10 power 3 Newton, which is 818 kilonewton. If you want to find efficiency, you should divide the strength of solid plate divided by strength of joint. What is the strength of solid plate? You have found out that 818, and what is the strength of joint? 271. Shearing strength, bearing strength of bolt, bearing strength of plate. What is least of that? Shear strength of bolt. So what is that? 271. That is the least. So you have to take the least and divide by the strength of the plate. So what is the efficiency you are getting? Only 33%. So what do you mean by this? You are providing two members, one is plate and another one is bolt. If you are providing a plate, you will get 100% efficiency. If any connection is being made, due to this connection, the member got only 33% of efficiency. Out of 100%, you got 33% of efficiency. Okay. Always for finding efficiency, the formula is strength of the plate divided by strength of joint. What do you mean by strength of joint? Least of the answers. What